Hello, my dear students. Welcome back to the lecture. So I hope that you have completed most of the BBS what I have taught you in the previous lecture and you were able to do it. Now we have another type of bar which is called as both the side crank. So for whatever we saw, it was an alternate crank, right? It was something like this. Your bar will come, you get a crank, it used to go like this. Then your next bar used to take from here, give a crank and used to take. This was called as alternate cranking of a bar. Sometimes you practice another type of bar which is called as both the side crank. So you can see it here. This bar has come, got a crank, it has come here, got a crank, and it has gone here. The next bar what you put, that will be a straight bar which will be in the bottom. Got it? After that again the same procedure. Bar will come, get a crank, go like this, get a crank, go like this. After that the next bar will be a straight bar. Got it? So this is how the slab BBS will be sometimes, slab execution will be sometimes done. Okay, you can see the same execution has been done here. Crank on this side, then again crank. So this is called as both the side crank. Again, for this also, the BBS what you're supposed to do, it's the same thing. You'll be having one crank on both the side. Next is straight bar, crank, straight bar, crank, straight bar. Then again, you'll be having a crank distributor. You see the top side, it's called as crank distributor here. This side also you have a crank distributor. This side also you have a crank distributor. And after that, you will get the top extra. So right now you cannot see the top extra because once the slab is completed, in between these two crank, you will get top extra, 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 top extra. Again, top extra, top extra, top extra. It is a one-way slab, so I'm going it full. Suppose if it was a two-way slab, then you know only your top extra will be at L/2 distance. Okay. Okay. Similarly, if it is two-way slab, I'll do it for two-way slab also. We'll bring a bar, give a crank here, take it here, give a crank here, take it here. Again, your next bar I'll consider take a bar, give a crank, take it here, take it like this, give a crank, take it like this, bar, crank, take it like this. Okay. And in between that, it will be a straight bar which will come in the bottom. Hmm? Straight bar will come. Straight bar will come. Straight bar will come. Got it, no? This is how you're supposed to do. And now, if I want to, yeah. And in between this, your top extra will come. Okay. Top extra will be over this bottom. Your top extra L/3, top extra L/3 or L/4, whatever it may be, top extra. Similarly, from here, top extra will come, top extra will come, top extra will become, and of course, the crank distributor also should come. From here, the crank distributor will come up to L/4. Crank distributor. You're getting my point, no? What I'm trying to tell. So everything is same. Only the thing is here on both the side the crank will happen. That's it. Okay. Yeah. Suppose if I want to draw a crank distributor on this side also, I'll do that. Suppose on this side also, if this side also your crank distributor will come. This side also crank distributor will come. Okay. Finish. So you know the top extra, only in this much length your top extra will come, which is L/2, L/2. Similarly, here also top extra will come. Top extra, top extra, top extra, top extra. Similarly, from here top extra, top extra, top extra. In between the two crank, your top extra will come. Got it, no? This is how it looks practically. So I don't have a, what you call a drawing for this, but I can teach you how the BBS for this has to be done. Okay, understood, right? So this video will not be played because in this particular session, that video cannot be played. It will get stuck. But I hope you got an idea how it has to be done. But again, it will be a continuous in practically, if you ask me, sir, how it looks, I'll show you practically how it looks. Okay, yeah. So practically what happens is, it will be something like this. So you give a, like, it will start like this. You brought a bar, you give a crank, you brought it, you give a crank, you brought it like this, crank. This way you brought, you give a crank, it will come here straight, then you got a crank. So in practical, this is how the bars will be put. But when we do the BBS, we'll do it for only one span. Like this span will take out separately, this span will take out separately. But when you real execution, the bar will be continuous. Since you have a 12-meter bar, so you'll be bringing a bar, giving a crank, take it, giving a crank, take it, giving a crank, take it, giving a crank. This is how we try to do. Okay, getting my point? No, this is how we try to do practically. But when we take out the BBS, single span, if you take out, it's well and good, not an issue. Okay. Mm. So you can see, how it has been done. So here everything is a one-way slab only we have done. Okay, this is covered in my site engineer course. That is a construction methodology course. I've explained you how these things are done. But anyhow, you got an idea now what exactly I am trying to tell. Okay, fine. Now to understand this in a better way, what I've done is I've taken the same image only for one slab. Imagine I'm doing a BBS for this. Okay, just you have to concentrate in this portion. Let us consider this is 5 meter. This inner to inner is 5 meter. This is 7 meter. For my easiness, I'm taking this. Already we have done that. Okay, and you have to find the crank length for this. So can you find this crank length for me? This can you find? Bar will start from here. Your bar will start from the center of this beam. Come here, crank, take it like this. Give a crank, take it to the center of this. Okay, fine. How you try to find? So first what you do? This beam is 230. 230 minus one cover. Again, this beam is also 230 minus one cover. This length and this length you'll get. Then you want to find this crank length. So this crank length usually it is L by 4 only most of the time. So from here to here it is L by 4. From here to here it is L by 4. Okay, got it, no? So L is 5000. So 5000 divided by 4. So this will be 1250. This will be 1250. This crank is 0.42 into H, considering H to be 100 mm. So again, this is 0.42 into H is 42 mm. This is also 42 mm. And the last portion which is left out is your center portion. How you will find this? This span is 5000. Out of that, 1250 has gone in crank here. 1250 has gone in crank here. If you deduct out of 5000 minus 1250 minus 1250, we'll get the straight portion. And you add everything, we'll get the total cutting length minus the bend deduction. So how many bend we'll get? We'll get 45-degree bend, because this is one 90-degree bend. This is second 90-degree bend. This is third 90-degree bend. This is fourth 90-degree. Very simple. When we had one crank, we had 2D deduction. Here the crank is on both the sides. So 2 into 2 is 4D deduction will happen. Simple. This much understanding you can have it. Yeah. Hmm. So if you want, I can do it here only, or I can directly go to the Excel sheet and do the calculations. I already done and kept it. We can follow the same thing. Okay. Yeah. So you can prepare a bar something like this. Very simple. You have to go to the shape option, insert, go to the illustrations, go to the shape, take a line from here, and you have to create a bar like this. Put a straight here. Okay. Go to the shape outline, weight, and you can increase the weight from there. Then again, Control C and Control V. Keep it like this. Okay. I'm expecting that you can do this. Then again, Control C, Control V. Take it like this and bring it straight. Then again, select this one, Control C, Control V. Okay. Control C, Control V. Okay. I think, okay. Okay. No problem. It has to be at top. And the last portion. Got it, right? You can prepare a shape something like this. Same thing I've done it here. And then you select everything and you say group it. Right click, group, and group it. Okay. This much you can do. Right? This much you can do. Okay. Fine. So now we'll start with the this part. What happened to, okay, I have grouped both the thing, ungroup. Okay, fine. Okay, fine. So I've written main bar along the shorter span. Number of member I'll consider to be 1. Diameter I'm using a 10 diameter at 150 center to center spacing, just for my understanding. So spacing, since we are doing alternate, because one crank will come both the side, one straight bar will come. One complete straight, one crank will come. So spacing will do double 300. Now this cutting length, 230 is a width, minus 1 cover, plus crank length L by 4. 5000 divided by 4 is 1250. So I got 1455. This crank is 42 because 0.42 into H, and H I'm considering 100 mm. Whatever you get from here and here, same thing will come here and here. Okay, this also will be 1455. The straight length will be 2500 because 500 is a clear span. Minus 250 this crank length, minus 250 this crank length. The straight portion what you get is 2500. Okay, fine. So number of bar, what you'll do, you have to take the opposite length. This length is 7000. 7000 divided by 300 plus 1 you do, you get 25 number of bar. Cutting length, you add everything. 1455 42 plus 2500 plus 42 plus 1455 minus 4 times the d. So minus 4 into d I have done. Okay, d is 10 diameter. So you'll get cutting length of 5.454 meter. Therefore total cutting length is 5.454 multiplied by 25 multiplied by 1 will give 136.35 kg running meter of the steel. Since it's a 10 diameter bar, 136.35 multiplied by 0.617 will be 84.127 kg. Now this is my crank is over. What is the next bar? The next bar what you get is a straight bar, isn't it? The next bar what you get will be a straight bar. Getting my point, no? This bar you will get next. This bar you will get. This crank I found now. This crank I found. I got the cutting length like 5000 something I got. So this crank length, cutting length I found. Next I'll find the straight bar. The straight bar anyone can do. This is that straight bar which will go like this. What you will do, you take outer to outer. That is from this outer to this outer. And then from here you deduct one cover. From here you deduct one cover. You'll get the cutting length of this. Getting my point now? And this length we know it is 5000. So we'll do the same thing now. So 5000 is a shorter span, plus 230 plus 230 minus 1 cover minus 1 cover. So it comes out to be 5410. So main bar along the longer span 110 dia, spacing is 300 because alternately you are going to place 300. So again 7000 divided by spacing plus 1 will not do because already here I have done the plus 1. So here again plus 1 I will not do. So I'll keep it as 24 number of bar. Okay. Cutting length will be 5410. So in terms of meter it is 5.141. So total cutting length will be 5.41 into 24 into 1, 129.84. So 129.84, since it's a 10 diameter bar, multiplied by 0.617, you'll get 80.11 kg of a steel is required. Now we'll do a comparison with one side of crank bar and with two side of crank, both the side crank. What will be the difference? Like if I go back to the this thing, this first project, what I had taken, how much we had, say this was 25 number of bar, this was 24, total it was 49 number of bar. So here also we have 25 plus 24, same thing I'm getting. So here I was getting 164.226 kg of steel is required. Here also 164.239. See here you are getting 84 kg of steel in both the side crank. In alternate crank it was 83. Hardly there is any difference. Again here it was 80.11. Here also it is 80.43. So the total answer is 164.226. So I'll do that calculation. This answer minus 164.226. So 0.013, 0. Yeah, 0.013 kg, there is a difference. So you can completely neglect that. So what I'm basically trying to tell is whether you do one side crank and straight and other alternate crank if you do, and if you do the crank on both the side, there won't be too much difference in the steel quantity. Almost it's a negligible amount, 0.0 you're getting. So you can follow whichever you want. But again, it will be mentioned in the drawing. Based on that only, you're supposed to do the calculation. Okay, fine. So I have done this. Shorter span, bar is done. Now we'll go to the longer span. Even though in the diagram I've explained you for this is practically a one-way slab, because in the opposite direction, if you see, this is your distribution still. But for my calculation, I'll consider this to be a two-way slab, considering the crank will come like this. So that if you understand a two-way slab, doing a one-way slab is very simple. I'm expecting that, I'm telling you that I'll consider this two-way slab and do the calculation, so that we'll be able to consider this as a two-way slab and we'll get the total answer. Okay, fine. I'll go in the longer direction now. So longer direction will look something like this, right? So this will be 1955, because this is 7,000 L by 4, that is 7,000 divided by 4 is 1750, plus 230 is a beam width minus 1 cover I'm doing. I'm expecting that you are able to understand this. Similarly, here it is 0.420 H. This time it is a longer span bar. So it will be over your shorter span bar. So that is why 100 minus 10 I am doing, because your main reinforcement is a 10 diameter bar. So 0.42 into 90, it will be 37.8. Whatever you got here, same thing you have to write here. Crank is also same. The straight length is 3,500, because 7,000 is the overall length. This is 7,000. This overall length is 7,000. Out of that, your crank is 1750 from here. Out of that, 1750 is your crank. Whatever the straight portion is left out, that is 3,500. So that is the reason I have written 3,500 here. Now you add everything, you'll get the total cutting length of this bar. So again, it's a 10 diameter bar. Spacing, I'm taking 150 center to center spacing. But since I'm finding this bar separately, the spacing will be 300. So number of bar will be 5,000 divided by 300 plus 1 I'll do. So I'm getting 18 number of bar. Cutting length will be, add all these things, 1955, 37.8, 3,500, 37.8 plus 1955 minus 4 into D. Bend deduction is minus 4 into D. So this will be 134.02 kg. Since it's a 10 diameter bar, 134.02 into 0.617 will give me 82.690 kg of a steel. So this bar is done. Then comes your straight bar, right? Again, if you remember, one crank and one straight will come, right? So now I'll find the straight bar. Straight bar is very simple. You know this inner to inner is 7 meter. This is 230 mm beam. This is also 230 mm beam. 7 meter plus 230 plus 230 minus 1 cover from here minus 1 cover from here. We'll get the cutting length of this. Okay. So we'll do the same thing. Yeah. 7,000 plus 230 plus 230 minus 1 cover from here minus 1 cover from here. So it will be 7410. 10 diameter. This is also 300 mm spacing. So number of bar will be 5,000 divided by 300. So no plus 1, because already plus 1 I have done it here. So you will not do the plus 1 here. So 70 number of this bar will come. Cutting length is 7410. This is 7.41. Total cutting length is 125.97. Okay, you know how it will come. 7.41 into 17 into 1 you do, you get 125.97. So the total weight will be 125.97 into 0.617. It will be 77.72 kg of a steel is required. Got it? So in this way, what we have done, main reinforcement along the shorter span, main reinforcement along the longer span we have done. Next, what is left out? Crank distribution is left out, and then the top extra is also left out. So try to practice up to here. In the next lecture, I'll explain you how to calculate the crank distributor bar on both the side and also the top extra. Okay, so try to prepare the Excel sheets. If you understand this, most of the part in the slab you are covered. We'll see you back in the next lecture. Thank you.